today's lesson is about arc length, and arc length is about finding the length of a curve. So suppose we want to find the length of a curve which is not a straight line. I call them curvy curves. How might we do this? So let me draw a picture, okay? What's been the technique for everything so far? Break it up into little pieces, right? And then
Go to infinity.
go to infinity. Look at each piece. So let's draw a little curvy curve.
I'd basically say that.
Yep, that's all good. A to B. And break your interval up into small chunks. And the width of each chunk is delta x, which is equal to b minus a over n, like however many pieces you decide to make. Okay, so then what you're going to do is look at each little interval. And what kinds of things do you know how to find the lengths of, specifically? Straight lines. So if I connect those points with a straight line, I could estimate the straight lines, right? That's how, I think, who was it? Maybe Archimedes? No, Euclid, I think, found the area for a circle. He took a circle and he put a polygon inside of it and a polygon outside of it, and then took more and more size in his polygon. Like what I mean by that is, like, you have a circle, put a square inside of it, okay? Then put like a six-sided gon inside of it, right? You could use that to estimate the circumference if you meant bigger and bigger and bigger. Okay, related idea. All right, now my picture is too small. I'm gonna draw a little zoomed in bit. So I have that A, my next point, and I have the curve. And I want to find this straight line distance. Okay, so how you can do that is you can use the Pythagorean theorem. So this makes a little triangle. You guys buy that? What I want is the hypotenuse, right? This base is delta x, how much x has changed, right? The height is delta y, how much y has changed. Now delta y will be different depending on where you are in your curve, right? But for every piece, you're going to have that delta x and delta y. So let's say then we have that, we'll call it L.
Oh yeah, we want to find length, that makes sense.
So the length of a little piece, we'll just say L sub I then, because it's one little piece, will be this.
Square root of delta x squared minus plus delta y squared?
Great. Square root of delta x squared plus delta y squared. That will be the length of one piece.
Yeah, how would we take that to infinity?
Yeah, now how do you take that to infinity? So you also have to account for the fact that delta y will be different for different pieces, right? So here's how you do it. You know that delta y over delta x is about equal to what thing from calculus 1?
The derivative?
Yeah. Do you guys agree with that? As in, it's about equal to the slope of the tangent line, right? Because you have a really small interval. So the slope of the line between those 2 points, which is called the secant line, will be really close to the tangent line. Or you can take that expression and you can say delta y is about equal to f prime of xi, and I probably should even say xi star because it's some random one in the middle, not the left or the right, just something, times delta x. And then you can take that and you can put it into your little length formula. So length of I will equal root. Substitution, exactly. Delta x squared. Delta y will be replaced by f prime of x sub I star delta x, the quantity, squared. And is there a greatest common factor that you can factor out from that expression now? What do both pieces have in common?
Delta x squared.
Delta x squared. So you factor it out and then you square root it, so it becomes delta x. This becomes square root 1 plus f prime of x sub I star squared delta x. And the whole star business on that f that x sub I just means you picked some sample point in between your A and B. It doesn't matter which one it is, it's just some random point in the middle. It could be the midpoint, quarter point, three-quarters point, left point, right point, whatever. So that's the length of one piece. One chunk. Can't spell and under pressure. Okay, so the total length would equal a sum of all these pieces, right?
And this is usually where it is something possible.
Yeah. And I should probably say approximately there because it's not exactly. That's an estimation. How do you make it exact? You take a limit as the number of pieces goes to infinity, and this becomes an integral. So the length of a curve is the integral from your begin point to your end point, root 1 plus f prime of x squared dx. So that's the formula for arc length. But it all goes back to that basic idea of the way to approximate something is to break it into small pieces and approximate the things that you can. The trick in this one was knowing to use this sort of substitution, right? Okay.
That actually, weird substitutions like that come up a lot.
They do, yeah. So that's the extra sort of thing to get over the hump. But the basic idea is break into chunks, approximate the chunks, like it is with everything else, right? Okay. So the arc length formula, and for this to work, you do need your derivative to be continuous on an interval, so just watch out for that. But the length of the curve is the integral from A to B, root 1 plus f prime of x squared dx. So the first thing you have to do when working out these problems is find f prime of x, and then to plug in and integrate. These integrals sometimes end up being notoriously difficult. So one thing we'll probably have you do on a test is just either give you a really easy one or have you set one up. Because the actual integration part is almost always really hard. Okay. All right, find the arc length of y squared equals x cubed between the points 1, 2, and 4, 8. I made a bit of a typo. This should actually say 1, 1. You see, 1, 1 actually works in the equation, 1, 2 does not. I just made a boo-boo.
Yeah.
Oh, because there'd be no way you would get that.
Yep, my bad. No, 2 keys right next to the 1 key. It happens sometimes.
But
Okay.
4 cubed isn't 8. 4 cubed isn't 8.
Yeah, but it's 4 cubed equals 8 squared.
I
Right?
didn't see that.
Yeah, so since it's y squared equals x cubed, that's right.
Yeah.
Okay, now technically this won't be a function. Like if you were to graph y squared equals x cubed, because it wouldn't pass vertical line test, right? I think. Yeah, definitely won't. Your calculator won't do it. So we have y equals square root of x cubed plus or minus, or y is plus or minus x to the 3 halves. Now, which part of that, if I have the points 1, 1, and 4, 8, which part am I looking at? The plus half.
I'd have to write it as a parametric and then probably.
Yep. Is everyone okay with why we're looking at the plus part of that? We have 2 positive points? Okay. So the length of our curve will be the integral from a to b root 1 plus f prime of x squared. So you need to find what f prime is.
Is it the average of the 2 derivatives, or is it just
Nope.
the derivative of whichever one is positive?
Oh, no. Because the points we had were positive points. That means we're looking at the positive part of the curve. That's why. So what is the derivative of x to the 3 halves?
3 halves x to the 1 half?
Yep, 3 halves x to the 1 half. Okay, and what goes in for my a and my b?
1 and 4?
1 and 4, exactly. Root 1 plus, 3 over 2 root x squared dx.
Nice, I found the difficulty.
There's slight difficulty. So you have the root 1 plus, what happens when you square 3 over 2 root x? 9/4 x.
I'm not really seeing why this one's so terrible.
This is one of those ones that is not terrible. I was going to give you a terrible one on the first one. I'll wait for the third one for that. So, what do you want to do next? I mean, you could do lots of things. You could do a u substitution. You could get a common denominator. What do you think? U substitution? I think that's okay. We're going to have sort of fractions somehow. Can I do a u substitution after I get a common denominator?
Or can you do the tangent thing?
Do you see? No, you don't need to do the tangent thing.
Okay.
Why not? Good question, though.
Because it's not the denominator, so it's easy to just...
Nope. It's just x. It's not x squared. Right? Remember that? Okay. So let's get a common denominator inside that ratio, or inside that radical sign.
Why do you need one?
It's just going to make it a little bit nicer. You don't have to have one. I just want to.
Just like you said that whole thing is u, then the 1 goes away.
So 1/2 integral 1 to 4 root 9 plus, or 4 plus 9x. I'd like my bounds to be whole numbers is all. That's what I'm thinking about. Does that make sense, Devin?
Oh, yeah.
That's why I'm changing them. I got the common denominator. 1 to 4 root 4 plus 9x. Is it clear where my 1/2 came from? Yeah, so you have this, both things are over 4, right? Which is like a quarter. And I factored the 1/4 out and it got rooted, it became a half, that's why. Okay. And now let's do a u substitution. So what's u gonna equal?
4 plus 9x.
U equals 4 plus 9x, u equals, shake the screen. Du is 9 dx, yep, 9 dx. And if x equals 1, what's u? I think 13, is it 13?
Yeah.
If x is equal to 4, u is equal to 40. Okay.
It didn't necessarily get nice.
So 1/2, no, it's not going to be nice. 1/9 integral 13 to 40 u to the 1/2 du.
13 to 40?
Yeah, I was just testing. You're still awake on this lovely Wednesday morning.
We really need to rename these numbers.
Rename them to nice things?
Well, so you don't confuse 14 and 40 or 13 and 30.
Yeah, you should do these numbers in Russian. It's even worse. Okay. All right, 1/18. Okay, what's the antiderivative of u to the 1/2? 2/3 u to the 3/2. Awesome. From 13 to 40. I drew a 14 again. Crap. It's Wednesday. That's.
And now we're doing it.
Yeah. So 1/18 times 2/3. 18 divided by 2 is 9. I think that's 1/27th. And goodness, we have 40 to the 3/2 minus 13 to the 3/2. That's just not going to come in nice. Let's just like, whatever.
Can we just leave it exactly?
Yeah, just leave it like that, seriously. It's approximately 7.63. Like, I'd like some exact answer, but that's good enough.
Well, what decided to take the top one?
I think so. I'm pretty sure. Okay, if it doesn't, if you get something that's not, let me know and I'll check. Yeah.
This line is super generous with simplification.
Yeah, I think that is definitely true. It's not generous with rounding. A simplification, yes.
I've left these long equations out of
And that's been fine, yeah. Say that again? Oh, because, no, you only have to look at the x coordinates. Is that what you're asking? Because I gave you the x and y coordinates. Kind of like when you do like disc or shell, you'll only look at you'll only look at the x or the y, not both. It's the same kind of idea. Since we have x's in our equation, we're just looking at x's.
Well, technically, the way you wrote it, we could have done it either way.
You technically really could have. If you'd solved for x, you can actually use the formula length equals integral from C to D, root 1 plus, we'll say, f prime of y squared dy. I think that will actually also work. I'm pretty sure it will. So you just kind of,
It may be
you kind of reverse everything, no, but I think that that does actually work. So, okay, how about the arc length of this strange curve? Y is natural log of cosine. Oh, well, you need to find y prime, right?
So that's 1 over cosine times negative sine?
Yep, 1 over cosine x times negative sine x, which simplifies to what trig function?
negative tangent.
Negative tangent. Ooh, okay. So length equals integral a to b root 1 plus f prime of x squared so 0 pi thirds root, what happens to the negative on that tangent when you square it?
Goes away.
Goes away. Okay. Yeah, 1 plus tangent squared is equal to something. It's equal to secant squared.
That was a nice trick set there. That's probably not going to be the case all the time.
No, definitely not, but I mean, this one was set up to work well for you. So you have the integral from 0 to pi thirds, secant of x dx. And I know I told you didn't have to memorize that antiderivative, but I think you probably did anyway.
I didn't.
Anybody? ln of secant plus tangent.
Oh, I thought that was a derivative for some reason.
Yeah, nope, it's the antiderivative. The derivative of secant is secant x times tan x. Right, yep. Okay, so we have a natural log of, okay, secant's 1 over cosine, right? So 1 over cosine of pi thirds plus tangent, which is sine pi thirds over cosine pi thirds, minus natural log 1 over cosine 0 plus tangent of 0. And I know when I was in Calculus 1, the unit circle was the bane of my existence, and I hated it and didn't understand it, okay? Don't be like me. That was a terrible way to live, okay? It's not that hard, and I was freaked out for no good reason. And the problem is nobody ever set me right until I had to teach it to a bunch of Algebra 2 kids at high school. And, you know, then if you're going to teach it right, you're going to have, like, you know, Algebra 2 revolt, and that's no fun. Okay, that middle angle is what? And then this angle and this angle, what's the lower one?
Pi over 6.
Pi over 6
And I think pi over 3.
and pi over 3. Okay.
Didn't like the upper one.
Yeah, all these things come from triangles.
1/2.
Yep. So that's the one you care about. And in that triangle, who's bigger, the base or the height? The height definitely is, right? So the base is 1/2 and the height is root 3 over 2. The reason it's those specific numbers is because the hypotenuse is 1, and that comes from the fact that you've got a 30, 60, 90 triangle. It's a special case of, like, geometry. But what I know is that I know that the numbers are root 3 over 2 and 1/2, and 1/2 is smaller than root 3 over 2, right? So 1/2 has to be the side to side, and root 3 over 2 is the top. Okay, so mini trig lesson over. So we have 1 over 1/2. Cosine's the x coordinate, right?
So wouldn't that create 2?
That would create 2. Okay, sine of pi thirds will be root 3 over 2. Cosine of pi thirds is 1/2. What would that make? Root 3. 2 plus root 3. And on the back end there, you have natural log of cosine of 0 is equal to what? 1. And natural log of 1 is equal to 0. So there you go. Okay.
I was about to ask the winner ones, you don't really need to go into why tangent equals 0.
Yeah, because tangent is sine over cosine, and, you know, 0 over 1 is 0. Okay. One last example, and you can do your quiz. So sometimes these problems involve really, really tricky factor patterns, and you'll know that's going to happen if you see something like this. It always ends up being a polynomial and a polynomial, well, not a polynomial, but an x in the denominator. That's a common tricky factor pattern. So the first thing you have to be really careful of is taking the derivative. So y is 1/6 x to the 5th plus a 10th x to the negative what power? Negative 3rd. So then what's y prime equal to? 5/6 x to the 4th, yep. 3x to the negative 4th. Is everyone okay with that much so far? Okay. So now when I'm going to do my arc length formula, I have to integrate from 1 to 2 root 1 plus y prime squared dx, right? That's the formula. So because I want to save myself time writing stuff over, and squaring this is going to be kind of gross, let's just square it and then put it in. Does that make sense? Okay. So we'll find y prime squared. So what's 5/6 x to the 4th minus 3/10 x to the negative 4th multiplied by itself?
Isn't that just the FOIL thing?
It is just a FOIL thing. It's just a little bit tricky because, like exponents adding negative stuffs, things happen. Okay, so easy part. 25/36, great. X to the 8th, awesome. Okay, how about multiplying this by that? Yes, do you guys agree with the 1/2? It'd be 30/60, right? Which just ends up being a half.
Why would it be 30?
Because you do 5 times 3. Wait, so
15
it's
over
15/60, it's a
times
quarter. I didn't, you're right, I'm one step behind you, okay? Yep, exactly, so minus a quarter. And I do the same thing here, right?
So that gives you another minus a quarter.
Which is what you were saying, this is minus 1/2, right? Yep. And then the last term is plus 9/100 x to the negative 8, right? Does that make sense?
Oh, we actually canceled out our x's completely in middle terms.
So you did, yep. So you have 25/36 x to the 8th minus a half plus 9/100 x to the minus 8. So far we're okay? Okay.
It does look easy to work with.
It's going to have a little trickery. Okay, go to the right side now. Let's plug it in. What happens when I do 1 plus this thing? So this thing plus 1 makes, I'm going to put it in there right away.
Plus 1/2.
It makes plus 1/2 in the middle instead. So you have 25/36 x to the 8th plus a half plus 9/100 x to the negative 8th dx. Is everyone okay with what happened there?
So do you know that you just figured out if they're not all perfect squares,
Yeah, it's not even, there's an even better pattern that's going to happen. That'll be the next step. So technically speaking, one related question, if you took this thing in purple and you factored it, what does it factor into? The answer's on the board, okay? What does this factor into? This thing squared, right? That expression squared? How is this expression different than that one?
No minus sign.
No minus sign. So what's this going to factor into?
Same with pluses.
Same thing, except there's going to be a plus in it. That's the tricky bit. That this factors into 5/6 x to the 4th plus 3/10 x to the negative 4th, the whole thing squared. And that problem was doctored super, super well to make sure that that happened.
Didn't the problem just be unsolvable?
Otherwise, yeah, probably, right? But since the problems that are in your homework are doctored to work, watch out for stuff like that.
For us anyways.
You'd create an unsolvable problem. So why this is not on like an in-class test, because it's just too much.
How do people do this in the real world where the real world isn't doctored to work?
Oh, it's a great question. So if you had an integral you couldn't find in the real world, what would you do? You'd use something like the midpoint rule to estimate it, right? Which I think is going to be like a question on a homework assignment. We'll do something with midpoint rule. But the point is, this one does actually factor. So 5, 6, x to the fourth plus 3/10 x to the negative fourth. And from there, even though it's kind of gross, you can do the rest of it, right? Like that's going to be 5, 6, x to the fifth over 5 plus 3/10 x to the negative 3 over negative 3, evaluated from 1 to 2, and after much patience and cursing, you get 1,261 over 240. Actually, in problems that are this gross, I kind of care about your antiderivative and then the arithmetic, whatever, just got it. I can't arithmetic either. Lesson on arithmetic, okay? So one of the problems was a work problem. It was like the integral from 0 to 500, and I think the function inside was 2x plus 800. Probably think that was number 3, perhaps, or number 2, however I numbered them, I don't remember. 2? Okay, and so you can do this two ways. You can do it as an integral like this, or you also could have done, how I did it in class, was made it the integral of 0 to 500, 2x dx plus 800 times 500. That's how I said that. And that's how it's going to come out if you do the whole integral as well, okay? Now.
I don't know where you get the extra 0.
Okay, so what's the so let's just do the one on the right. It's the same thing. What's the antiderivative of 2x? Okay, 0 to 500. Okay, when you multiply things with zeros, here's what I was taught in elementary school, or I learned the pattern, I don't know. Multiply the digits that aren't zeros. 8 times 5 is 40. And then count the remaining digits. How many more zeros you can add on the end? 1, 2, 3, 4. Put your comma in. How many people missed that? I was making me I was having a little bit of a freak out.
100 times 100 is only 10,000, and that's basically...
But the 8 times the 5 is 40.
So you got this.
That's where the extra 0 comes in, the 8 times 5. Yeah, so if you do, anyway, you can confirm that by doing whatever multiplication method you want to do. I know that's right. So, I'm just saying that the kicker is you have this 40, and then you add on the zeros that are from the rest of the zeros. That's the shortcut.
That explains why my words seem really
So,
low.
how about 250 squared then? I understand, 500. I knew it made it easier than that. 500 squared. So x squared. Yeah, so 500 squared is going to be 500 times 500, and the 5 times 5 is how many zeros? 1, 2, 3, 4. You get the picture, right? That's my quick arithmetic lesson. You should know about zero rules. If you don't know about zero rules, I don't know what happened to you. I'm sorry. It's not your fault. I blame your elementary school teachers, okay? Alrighty.
I just had a moment there.
Or just a moment. All right, so there you go. Alrighty. Oh, and the other thing, one last thing. On the fourth problem, the last one, why is it wrong to go from 0 to 2? And it was kind of harsh if you did this because you introduced stuff that basically... Because so the thing said t began at 8 a.m., so it should have been 1 to 3. But the other reason I was kind of mean about that, and there should be a 1/2 there as well, obviously.
It creates an indeterminate one.
Yeah, it's 40 minus 6 over t when you anti-differentiate, and then you're supposed to be plugging 0 into something, and most of you who made this mistake just ignored that you had 6 over 0, which is kind of not okay.
Now that made me start over.
Yeah, and that's a good thing. That's kind of what I was looking at. So, and I was also picky about the units on 2 and 3, but not, I took off a point if you had them wrong.
What were supposed to be the bounds then?
They were supposed to be 1 to 3, because t was hours after 8 a.m. Does that make sense? So it's just reading the questions carefully. I know it happens that when you get flustered, you don't read things correctly. Everyone takes tests, we get this. Just Take a deep breath, and if you're getting something strange, just try reading it over. So I took a stats test in my stats class yesterday, and this thing involved like the integral of some weird jazz like this. I mean, like it looks like totally crazy. And inside the exponent was what was it? Something minus 2 over 2. And I missed this whole like over 2 business when I worked the problem out the first time, and I couldn't make it work. I had to go back and reread it. And so that's the point of the story, is like everybody has to occasionally be forced to reread stuff, including me. So.
What's the name of your stats class?
Stats 651, it's a course in probability theory.
So it's a master's degree?
It's a master's level class, yeah. Okay, because I have math background, but not stats. Not as much anyway. Okay, so exact length of curve for ln of 1 minus x squared on the interval from 0 to a half.
I feel like we're now back on the worksheet.
We're back on the worksheet now, yep. Okay, so what is the arc length formula?
A to B.
Uh-huh.
Square root of 1 plus f times x squared.
Yep. Okay. So what is y prime of, if you have ln of 1 minus x squared, what's the derivative of that?
1 over 1 minus x squared
Uh-huh.
times 1 minus x squared.
Almost. Times the derivative of 1 minus x squared, which is negative 2x. In this case, the negative won't matter because you're going to square it. Does that make sense? Okay. So inside here we have 0 to a half, and this integral is gonna get kind of ugly, so save yourself some space, don't write ginormous. Okay. Root,
Thanks for the warning.
so yeah, I should try to do that more often. 1 plus 4x squared over 1 minus x squared squared. Has anybody been to my office and seen my great poster that says whenever you do this, a kitten dies?
Oh, yeah.
There is this like, it's like x squared plus 3x plus 2 over x squared plus 1, and they cancel out the x squareds, and that says whenever you do this, you kill a kitten. It's just a goofy thing that's bad algebra. Another kitten killing mistake, because I'm going to call them that now, is distributing square roots. So don't try to make that one up, okay? I'm gonna put kitten dead. I'll draw a kitten on your paper with the eyes X'd out. So,
You can only use the multiply, right?
say that again?
Use the multiply? Right?
If they're multiplied, then you can distribute the square root, but not over addition. Yep, exactly. Okay, so barring distributing a square root incorrectly, what else could you, that's not, okay, you can't do that, and there's no multiplication, you can't do that. What else could you do inside that root sign?
You could
Factor out the one.
Find a common denominator. Does that make sense? Like, what else are you gonna do, right? I don't see any other way to proceed. So integral 0 to a half is gonna be gross. Just gonna say it wasn't. So this was gonna be 1 minus x squared squared plus 4x squared all over 1 minus x squared squared. Does that much make sense? Okay. And now, well, your only option is to simplify that numerator, right? So that's the same thing as 0 to a half. 1 minus 2x squared plus x to the 4th plus 4x squared over 1 minus x squared squared. Is everyone okay with that part of it? Okay, so 0 to a half root. Now that's the same thing as x to the 4th plus 2x squared plus 1. If you saw, I'm going to do that in 2 steps, but you can totally do it in 1.
Can you spread out the denominator so you can cancel anything?
Nope, that won't work. That would be a kitten canceling kind of thing if you did it.
I meant like canceling out via the division thing, long division.
Oh, you could, yeah, doing long divisions may be possible, but I think it would probably,
You'd probably end up just getting back to what you had.
yeah, I don't think it's yeah, yeah,
It's
no,
not gonna help
no,
us.
I think it's not gonna help at this stage. But what Mitchell said is the right thing to do, so could you repeat what you said? The numerator is,
But it is 1 plus x squared all squared.
yep, or x squared plus 1 all squared, right? Do you guys see what he's saying there? that numerator now actually factors into x squared plus 1 squared, and you have that over 1 minus x squared squared. You see how that's why is that helpful? Now you can distribute the root to the numerator and denominator, because the roots do distribute over multiplication and division. That's all good. So now you're at the stage 0 to a half. I'm going to write that as x squared plus 1 over negative x squared plus 1, just to start.
I had a question.
Someone said move it up, right? Okay, yep. And then question?
So, there's this technique where you can add something inside your integral if you do the opposite, like if you...
Yeah, you can add and subtract stuff. I don't think that's the way to go in this problem, but it's a totally legit technique.
I'm just asking would it work if you do it. Let's say you had something that you couldn't factor out, and you brought it inside of the integral, inside of the square root.
Then you would square it.
Yeah.
Yeah.
So could it be a way for you to solve the problem?
It depends on the problem. It's really problem specific, because there's no great general ways to solve things like, there's no awesome general solving techniques. So it's possible, but I'm not sure. Okay, yes, Desmond, and then Corey. Okay, Corey?
I did this problem on the homework when I finished and stuff, but for some reason, what I did was I accidentally multiplied out the denominator first.
Okay.
But then I switched it to x squared minus 1.
Oh, okay.
C squared,
I don't mind that.
I got the wrong answer. And
You shouldn't get the wrong answer if you do it right. Like, it probably is just a sign error. But here, does everyone agree that I could take out the negative? Like, I take out the negative, and that could make it 0 to a half x squared plus 1 over x squared minus 1. Do you agree with that? And that's totally legit. Let's just do that, okay? Because there's nothing wrong with that. But you probably made some kind of little sign error after that, because it's not a wrong technique. It's just something probably happened. Okay, and now at this stage, this is we're into the section 7-4 territory, which is partial fractions. Ah, yeah, okay, so first of all, I have a ratio. Now, can I make the partial fraction decomposition right away? No, what do you have to do first? Okay, I'm going to make a long divide bubble, okay? This is like my work bubble. I'm so sorry. These problems get nasty. So x squared plus 1, we're seeing how does x squared minus 1 go into it. It's not a very hard long division. So it's 1, right? X squared minus 1, take it away, and then what's your remainder? 2. So what we have then is 1 plus 2 over x squared minus 1. That's our, post long division stage. Does that make sense? Yeah, let me finish first, okay? I understand you did it differently, but let me finish. So now what do you do after that? With this part specifically.
Then you
do the partial fractions thing, right? Yep. So 2 over x plus 1 x minus 1 is going to equal a over x plus 1 and b over x minus 1, right? So 2 equals a times x minus 1 plus b times x plus 1. And is it at least one of the easy ones? Yeah. So if x equals 1, what do you get? What goes away when x is 1? A. You get 2 equals 2b, therefore b is 1. And what's the other number you plug in? Negative 1. And you get 2 equals negative 2a, therefore a is negative 1.
Yeah, what you do with that afterwards?
Okay, afterwards, negative, so equals, don't lose that negative sign.
And we're back over outside.
Back over there, yep, 0 to a half. We have 1 plus negative 1 over x plus 1 plus 1 over x minus 1. Does everyone agree with that? All that work was done to break that integral up. Where did the whole, I'm just gonna move that in for just a second, where did the whole 1 plus come from?
Because it was at the very top.
That came from the long division, so that's from right there, right? And then this part broke down into that sum, right?
That's where you put that.
Exactly, and then you plug it back in. And now it's not awful, it's not very pretty either, but it's not terrible.
It's
So
possible
negative,
is what it is.
exactly. So what's the antiderivative of 1? X minus natural log absolute value x plus 1, right? Plus natural log absolute value x minus 1. 0 to a half. And then just plug stuff in. So negative parenthesis a half minus ln of 3/2, right? Plus, what's the next one? ln of, which then you absolute value and you get 1/2.
Would it be quicker to just combine the LNs?
We can, and then plus blah, blah, blah. I think everything else is 0, isn't it? Because you get natural logs of 1s, which are 0s. Okay, so plus 0. So what we have here is minus a half plus ln of 3/2 minus ln of 1/2. And that's good enough for me.
Is natural log for -1 0, so?
Natural, well, the -1 gets absolute valued first,
Oh, yeah.
and then you take natural log of it. Otherwise, you can't actually do natural log of -1. It's not defined. The absolute value bars are necessary there.
Natural log of 3/2 minus natural log of a half is natural log of 3.
Yeah, did you guys see how we got that? Natural log of 3/2 minus natural log of 1/2 is natural log of 3. Remember how logs can combine? And that combines into log of 3/2 over 1/2,
Oh.
which does become log of 3. Do you agree with that? So you don't have to do that like on a quiz or a test or anything. I think even WebAssign won't tell you that you're wrong, but if you're like checking your answers against Wolfram Alpha or something like that, it will definitely do that. Okay.
So I think the problem was when I factored it while it was in the square root to x squared minus 1, I think? Yeah.
Okay.
So it came out as x squared plus 1 over x squared minus 1. But I think that had to be negative, but like,
Probably, yeah, you just must have made some small sign error.
no, because
Can you ask me after class? Because like this is more useful for you.
the negative of that.
If your answer was the negative of what this is, what you missed is that negative sign right there, somehow. And it's gonna make more sense if I answer your question after class, because everybody else, like, you know, just a little bit, let me talk to you after class about that one, because I'd like to actually finish some of this stuff. Yeah,
Back to the long division. If you know that 1 over x squared minus 1 is tanh, you do tanh of negative.
no, you don't know that you know that the no, that function is not equal to arctangent in any way, shape, or form. No. The antiderivative of it, sure, and actually it's the antiderivative of 1 over x squared plus 1, but it's only if you're anti-differentiating it. It's not like the functions are equal in general. Like, this is not true. Totally not true. Tan inverse of x is not equal to 1 over 1 plus x squared. That's wrong. How would I make that a correct statement?
Derivative?
Put a derivative right there, or put in antiderivative sign right there. Then it's true, but it's not that the functions are equal. That's false. If you do something to this function, you get that function. And something you do is take a derivative. Or, from right to left, take an antiderivative. The functions aren't equal. Graph them. They look nothing alike. Okay. So, sometimes it's useful to have something called an arc length function. So, what this means is that instead you find the length from a point to a random point, and then you can plug in a different number for that random point. So like suppose I have this curve, and I know it starts here and it ends there. And I want a function that tells me the length of the curve up to any point in the middle. Does that idea make sense? Up to any point x in the middle. Hello. So instead of integrating from a to b, I'm going to integrate from a to x. So a up to some random point. And then you have to use a different variable inside of your integrand. So a common thing is to use t. since that's what we're gonna do in this class. And then you can plug in any x number between a and b to figure out, and it's like the s of, if you want to find the integral from a to b, you just plug in x and you're doing the integral from a to b. But the thing is, you can actually do this integral and then plug in x for the t's, and you're going to get a formula, so you don't have to repeatedly do that integral for changing points. Does that, see what I'm saying there? So you can find the length from a to any endpoint x, where x can be anything. So let's look at an example. You saw stuff like this in Calc 1 a little bit, didn't you? There were things like, here's this function of x, and it's equal to an integral from a to x, and it was like, I don't know, t squared plus 1 dt. Right, remember that? And it found the area under the t squared plus 1 curve up to each x's that were changing. And that would represent the area underneath that curve from a to some other value. It's called the cumulative area function. It finds the value from a up to a number. Probability uses that all the time. Like, what's the chances you're under this curve that has a probability meaning to it from a number to another number?
So if you set the function equal to a value, you can find the value of x that would give you that value.
Let's do an example, okay? And I think you guys... Okay, so suppose we have the curve x squared minus 1/8 ln of x, and our starting point is 1, 1. So I want to find this thing called the arc length function. So that's going to be what they call s of x. And it's an integral from a to x root 1 plus f prime of t squared dt. It's really no different than the other stuff we've been doing, it's just except you're going to have an answer that has x's in it, not an answer that's a specific number. Okay, so what goes in for a is your starting point, and specifically the x coordinate of a starting point. So that is, in this case, 1. The endpoint is variable. You don't know what the endpoint is. And root 1 plus... Okay, so if we change those x's to t's, we have t squared minus 1/8 ln of t. What's y prime then?
2t minus...
1 over 8t. Do you guys agree?
Okay, yeah.
Yeah? Okay.
I was just wondering if you're supposed to convert that to 1/8 into a exponent before you did it.
No, don't have to. So is everyone okay with what I did there? Just put in 2t plus minus 1 over 8t squared. Okay, so then multiply that out. Root, so that's 1 plus 4x squared. Oh, 2t minus 1 over 8t, 2t minus 1 over 8t. Okay, so that's 4t squared.
Minus a half.
Minus a quarter, minus a quarter. Yep, so minus a half. And then plus, what's the last thing?
1 over 64 t squared.
It's one of those weird ones, isn't it? 1 over 64x squared. That should be t's. Yes, thank you. Is that what you're raising your hand for? Yes. That should be t's. Oh,
And I didn't even bat an eye.
no. No one did. 4t squared minus a half plus 1 over 64t squared. We didn't do any integrating yet, so I don't need to change the bounds. Ooh, but it's one of those strange ones. Do you know what I mean by those strange ones? The ones that you kind of have that middle term then becoming positive and then it factors? As in this 1 plus that negative 1/2 all of a sudden makes this into positive 1/2.
Do they have to be doctored?
Oh, they totally have to be. That's why it's 1/8 ln of x. I mean, it's doctored to work out. Definitely. So that's the integral from 1 to infinity root. So that, how does that stuff factor then? 2t plus 1 over 8t squared. And then that allows you to actually do the square root, right?
Where'd the 1/4 go?
Well, there was a negative 1/4 minus a quarter, which made negative 1/2.
Yes, but you factored it out.
No, I didn't factor it out. You see how I had this, there's this 1 plus, that's part of the formula?
Yeah,
And so I did 1 minus a half.
then you got plus 1/2.
Yep, yep.
And then I assume that your next step was factoring that out.
Yeah, but look at this. This expands into this, right? Okay, how is that red thing different than this thing? What's the difference?
There's a 1/2 there.
The difference is it's a positive 1/2 versus a negative 1/2, right?
Yeah.
So then this thing had to come from that expression except for the plus squared.
Oh, so
And the
factor
1/2, the
that.
1/2 is inside of that, but it hasn't multiplied together yet.
So you factor.
Yeah, if I multiplied, combined like terms, and then factored again. So, yeah, these tricky ones are always gonna involve that. And a kicker that you're seeing is you have something where you have a middle term being a constant. So then the integral becomes 1 to x 2t plus, I'm gonna write that as 1/8 times 1 over t. I think it'll be a little better to integrate that way. Can you anti-differentiate now? What do you get?
T squared plus 1/8 natural log of t.
From 1 to x. And then plug in your stuff and you have, what's that? X squared plus 1/8 natural log of x. I think just minus 1. Okay, and that's this function that they call s of x. And this tells you the length, length of curve from 1, 1 to some random point x, f of x, like whatever that point is. Okay, let me finish the rest of the problem, then you can ask me questions, okay? So the rest of the question said that approximate the length from 1, 1 to 3 f of 3. So how would you find the length from 1, 1 to 3 whatever, using this formula? Just stick 3 in. S of 3 would equal 3 squared plus 1/8 natural log of 3 minus 1, which is 8 plus 1/8 natural log of 3, whatever that is. And the only thing that's a little bit fussy here is that your starting point is actually like a fixed number. Does that make sense? Like it actually is built into the formula. You could make one really general where both the top and the bottom bounds were variables, and then you'd have, assuming the bottom was less than the top, you could have formula for whatever, what you wanted. Okay, yes?
How is this different than the other formula?
How is it different than what?
The other one, the one you used previously?
It's not. It's just that you get a formula out and not a specific number, and you can use this to find lengths for lots of different x's.
Okay.
Yeah?
Okay, so once back to the part where you saw that the negative 1/2 replaced the positive 1/2, it then came out to where your function you get from the integrand is just, you.
I think that pattern's always gonna happen. Okay, yeah. All right, so let me finish. So, often arc length problems give you stuff that's not possible to deal with. And so you have to use approximation techniques to deal with the integral that you get. So let's just set one up and talk about how you would apply a rule to it, okay? So suppose we were going to use Simpson's rule with n equals 10 to estimate the arc length of this curve, y equals e to the negative x squared. So to find the arc length, what would you first of all need? You'd need the derivative, because the arc length formula is integral from a to b root 1 plus f prime of x squared. So what is f prime or y prime in this case? What rule do you have to use to get the derivative? Chain. So the derivative of e to the negative x squared is?
E to the negative squared.
Times negative 2x. So that becomes the integral from 0 to 2 root 1 plus, what do you get when you square it? I mean y prime. y prime squared, oh, this is a good question. Negative 2x e to the negative x squared squared. So I think it's pretty obvious you have 4x squared, right? That part's easy enough. What happens with the powers? So, yeah, negative 2x squared. Remember when you have a power to a power, like x squared to the 5th, those things multiply, right? Same pattern here. Okay, and that one, not gonna solve nicely. So what we're gonna do is we're gonna use Simpson's rule.
You can even try and like back.
No. Okay, n equals 10. So what is delta x for Simpson's rule?
So,
2 minus 0.
So 2 minus 0 over 10, 1/5?
Perfect. Or 0.2, either way, right? What function are you going to be using for Simpson's rule? Like, what's the thing you're going to plug stuff into? Simpson's rule approximates like the area of under a curve, right? That's what that integral tells you. So the area under some weird, crazy curve, right? The thing you plug stuff into is not the f of x that you were given, but the f of x that's inside the function once you do the setup. So the f of x you're going to plug stuff into is 1 plus 4x squared e to the negative 2x squared. Right? So then S10, I'll just start the setup, will be equal to 0.2 over, what part? 3? And then first you plug in, and then what's the next coefficient?
4.
F of 0.2 plus 2 f of, what's the next number?
0.4.
0.4. Blah, blah, blah. What should your second to last number be? 4 f of 1.8. And lastly, you should have f of 2. That should come out to be approximately 2.28 about.
May say with that 2
But the kicker is that the function that you use is the function that you get once you set up the integral. Does that make sense? Which is related to but not the same as the original function. Okay, that's the thing. And I don't want to give you things, hopefully I didn't give you S10 on your WebAssign because that's like a lot of buttons to punch. Hopefully it's like more reasonable S.
Question?
Yes. Yes.
Could you have used another formula instead of, let's say, the midpoint rule or something more accurate too? I mean, could you have?
Theoretically speaking, if the directions say yes, like you could also use the midpoint rule to estimate this. It's not like that's wrong, but when the directions ask for Simpsons, you have to follow it. But yeah, the midpoint rule would work the same way, except for you'd be plugging in numbers like 0.1, 0.3, etc., right? And then you still plug them into this function. So the how you do it doesn't change, and the kicker in that case is you apply the rule you know to the integral that you're given after you set it up. Yeah. Okay, one last one. I think it's a great application question. It's something to write to me and say, hey, I had this question, happened to me in real life. It's a great question. Okay, so you have a piece of corrugated roofing, which happens in life, right? Yeah, people have roofs like that. And the piece is 28 inches long and 2 inches deep, okay? Do you make sense? From lowest to highest point is 2 inches tall, okay? You want to find out how long was the sheet that got compressed into that. Does that idea make sense? That's the same thing as finding the length of the curve. Right? This is a little bit algebra 2-y, but this you could think about as a sine curve, because you can pick sine or cosine, who cares? If its highest to lowest point is 2, what's the amplitude of said sine curve? 2. Amplitude is actually 1. So it goes up to 1, down to negative 1. So it does something like...
basically actually a sine curve.
It's a sine, yeah, you can think about it as a sine curve, right? And then how long does it take it to go through, how many cycles does it go through here? I think it goes through 2. Do you guys read that?
Yep.
Okay, so this, if we just said that's 14, that's 1 cycle, right? So they told us that the equation is sine of x over 7. I just wanted to remind you how that works. So inside, if I gave you a general sine curve, like sine of bx, whenever that number x, b times x equals 2 pi is when you've gone through one cycle. And so in this case, the number that goes in for x that gives us one cycle is 14. So b times 14 is equal to 2 pi. And that's how they got that little b is pi over 14. Yes, thank you. Pi over 7. So that's where that came from. Does that make sense? Okay. So for our length,
So if they hadn't told us the formula, but.
you could have figured it out.
Yeah.
But I think that this equation, like I copied it out of the textbook, they gave you the formula, so it's actually not that hard at all. So if you want to make a 28-inch panel, that means that you're integrating from this sine curve from x equals where to where? 0 to 14 would do half of it.
Okay.
So 0 to 28. You could do 0 times 14 times 2, that'd be fine. And then root 1 plus, so the derivative of this, if y is this sine of pi over 7x, what is y prime? Pi over 7 times cosine pi over 7. So that'd be 1 plus pi squared over 49 cosine squared of pi x over 7 dx. And then it says use your calculator. They assume you have a calculator that can integrate, but given take-home questions, you have the internet to help you integrate, right? So this is approximately equal to, or to 80 something, yep, 29.3607. I think it's kind of a cool question because you can see how it definitely would actually matter, right? A little bit. Yes. The units would just be inches. Yep. If you were just asked to find the length. Yep.
I feel like that's not that matter. That shouldn't work.
And they said to find the width. It does. I'm afraid I have to move on because I got to talk about surface areas yet. Okay. So. I'm so sorry.